Hello everyone, welcome to Wi-Fi Learn. In this video, we can see the definition of an electric current. See, the current is produced due to the movement of charges. Let's see these charges, how they are moved to produce the current in the conductor or in the closed electrical circuit. See, we know that the molecular structure of an atom consists of three charging particles. First is a positive charge named as proton, and next is a electron of negative charge, and third is a neutron, neutral charge element. This proton and neutron will present in the nucleus, where electron will present on the outside shell. That nucleus will be present, where this is an electron, this is a nucleus. In nucleus, the protons and neutrons will present there. So, this electron will be in the outermost shell of the nucleus. In some materials, these electrons are tightly bound to the nucleus, whereas in some other materials, these electrons are loosely bonded. These loosely bonded electrons have the tendency to move throughout the material, so that it constitutes an electricity. See, the electrons present in the outermost shell has the weakest bonding between the nucleus. Okay. The electrons present in the outermost shell will have the weakest bonding with the nucleus. So, this electron has a tendency to move. So, this electron is termed as a free electron, where it can move throughout the material. So, the material has a tendency to move the free electrons, and that material is termed to be conductors. See, a conductor is a material that allows an electrical charge to move through it. So, this movement of charges constitute an electrical current. Normally, the charges tend to be in electrons. These free electrons are aligned in one direction, so that the movement of these free electrons are termed as a drift, drifting of an electrons or drift speed of an electrons. So, this drifting of an electron causes an electrical current, or from one terminal to the other terminal. So, this movement of free electrons constitute a current. Movement of free electrons in conductor, free electrons in conductors are termed as drift. So, this movement of electron causes a current, that produces a current. The examples of elements of conductor are silver, gold, aluminium, copper and iron. And the elements that do not allow the free electrons to move, that is, that resist the free electrons, that resist the electrons to move, are termed as an insulator. Insulator is the material that hinders the flow of the electrons. It is opposite to that of the conductor. So, examples of insulating materials are wood, plastic and glass. Since insulators, the nucleus and the electrons are strongly bonded, it cannot be braked, so that the electrons cannot be moved in an insulator. Whereas in the case of conductor, it has more free electrons and it has a tendency to move. See, in this picture, the electrons are aligned in some other direction. How these electrons are moved from one direction to another direction? Without any force, it cannot be moved, right? So, we have to apply some force, so that these electrons are moved in a particular direction. So, that force is termed as a EMF force. We have seen it already, right? So, EMF is nothing but a force that pushes an electron from one terminal to the another terminal. See, this is a conductor in which it has more number of free electrons in it, right? Assume this as a free electrons, and you are giving an external EMF. EMF can be of, I am giving here as a battery, EMF source. So, once you apply this EMF source, the free electrons present in the conductor will align in this way that it flows from negative terminal of the battery to the positive terminal of the battery. Since electrons are negatively charged, it attracts oppositively charged particles. This opposite charged particles would present in the positive terminal of the battery. So, it is moving from the negative terminal to the positive terminal of the battery so that it constitutes a current termed as electron current. Electron current. The electrons are moved from the negative terminal to the positive terminal of the battery once it gives the EMF, unit of current. How the current has been produced? It is due to the movement of charges. Assume Q is a charge of 1 coulomb that is flowed in the conductor of 1 second. 1 second time. Now let us see the current equation and we can find the unit of current. Current is nothing but a rate of flow of charges, right? Rate of flow of electrons. So current I can be given by the ratio between the Q by T. That is nothing but a rate of flow of charges for a particular time. We have already took the charges as 1 coulomb for 1 second. So the current constituted for 1 coulomb for 1 second would be of 1 ampere. 1 coulomb of charge has 6.24 into 10 to the power 18 electrons. So to get 1 ampere of current, we need 6.24 into 10 to the power of 18 electrons to move for 1 second. So that it constitutes 1 ampere of current. Unit of current is nothing but an ampere. Unit of current is an ampere. Flow of 1 coulomb of charges for 1 second constitutes 1 ampere of current. 1 coulomb of charges is nothing but 6.24 into 10 to the power of 18 electrons. So to get 1 ampere of current, we have move 6.24 into 10 to the power of 18 electrons for 1 second. So the unit of electrical current is an ampere. On the basis of flow of electrical charge, current can be classified into two types. One is alternating current and another one is direct current. Direct current, charges flow in one direction. Whereas in the case of alternating current, charges flows in both the direction. So it is a basic definition about the current. This current is due to the movement of charges. Mostly current is produced movement of the electron.